Today's section is real similar to yesterday's. It's going to be 6-5, but instead of percent increase, we're doing percent decrease. So this will be when we have something going down by a certain percentage, and it could be something on sale, could be something reduced price, I guess same thing. Okay, so percent decrease, we'll just start out kind of defining it and say that this kind of percent decrease, what's that really saying? It's saying when something goes down by a certain percent. When something goes down by a certain percent. It's easiest to come up with the money examples, at least in my head, but you could do other things as well. Somebody loses a certain percent of their body weight. The average earnings of the middle class, they're talking about that a lot right now, is down by a certain percentage. And the key is going to be this here, so I'm going to put it in large with a box around it, that when you're doing percent increase, the last section we always did like 100% plus the percent increase. Now we do the opposite of that. That when you're doing the problem, you always do 100% minus the percent decrease. So 100% minus the percent decrease equals the percent in the problem, or equals the percent that you put into the equation. But there's the main thing. I used to do this when I taught Algebra 2 before, and that was the big mistake that people made, is they forgot to subtract their percent decrease from 100% before starting. So for example, say you're going to buy something, it's 10% off. What you would do, and I don't think I'd write this down, we'll do this in the example, but if something's 10% off, well, if you start out with 100%, you're taking off 10%, you're left with 90%. So now as I go through and do the calculation, I'm going to use 90% or 0.9 in my calculation. That's kind of where we're going. So I want to throw three examples at you. If you look at your I can statements for this section, you'll notice that there's three things. And it's going to be basically for each of the three examples. So I'm going to start out saying that we have a new car, and that new car is going to cost $23,500. And right now it's 35% off. So a new car, $23,500, is 35% off. What is the sale price? So that first step is just going to be figuring out, well, what percent do I put in the problem? A lot of you have already probably jumped to it, but just to kind of cover my bases, I'm going to say, well, originally, you have 100% of the car's cost. They're going to take away 35%. So what percent is going to be left that you have to pay? Well, 100 minus 35 gives me 65%. So now we need to use this 65% in the problem, because that's the percentage of the original cost that you have to pay. Well, I would recommend doing it kind of the shortest way, less chance to make mistakes. And yesterday we were saying that instead of the percent times the whole equals the part, I think it might make a little more sense if you say the percent times the original equals the new. So my 65%, when using this equation, we always put the percent in as a decimal, so that'll be my 0.65. The original amount of the car was the $23,500. We put that in this original spot, or you could say the whole amount. Then we're looking for the new amount, or that partial amount. If I take my calculator, punch in 0.65 times 23,500, I come up with $15,275. Probably not getting much of a car, but at least for this example, you'd be paying $15,275. Sometimes people like doing it the way where we did with the proportions. I'd encourage you to do this way here on the left. I'll at least do the proportion one time, so just for this first one. But before we were saying that you had the part divided by the whole. If you're not a proportion person, I'd skip this if I were you. But part divided by the whole is the percent over 100. Actually, I think I usually did those the other way around, left and right. But then, well, we have 65 over 100, because we're paying 65%, so we still had to subtract the 35 from the 100. And then the whole amount was the 23,500. So 23,500. And we're looking for that part. So now when we do our cross multiplication, we have 100 times x equals the 23,500 times 65. Almost got it in there. And then, I'm sorry, 100 times x equals 23,500 times 65, which would then give you 100x equaling 1,527,500. But then last step, we divide that by 100, which you can knock off 2 zeros off of each, giving you that same final cost of the 15,275. But like I said, I think if you go with this way here on the left, it's shorter, it's less chances to make mistakes, it's faster. Recommend that. Alright, then my next example. This example here is going to be where we're trying to figure out the percentage. And I'm going to say hiking boots. I'm going to try to keep this one short, but you have hiking boots. They're originally 225. They're now are $157.50, so 157.50. And then you could say what percent off. When you're doing these ones, you have to make sure you take your final answer and remember that that is what percent you're paying. So to figure out that percent off, you have to figure out what did they take away from 100 to get that. So my preferred way of doing this is to say, alright, we're going to do my percent times the original equals the new. And I'm going to take and put in my numbers from there. I'm going to say, okay, so my $225, that was my original amount. And my new amount, what I'm actually getting charged, is the $157.50. So the unknown, the thing we don't know, is that percentage. So I'm going to turn that into an x, because we're a little bit more used to solving for x. And to get x by itself, well, x was multiplied by 225, so we need to do the inverse of that. We divide by 225. And when I do that now, I come up with an x value of 0.7. So then a lot of people there think, okay, well, it's 70%. And that's true, we're paying 70%, but kind of like what I was alluding to before, we're saying what percent off is it. So if you put down 70%, no, you're not getting that good of a deal. Instead, it's going to be 30% off. Would be your final answer. And a lot of people would probably just look at that one at least and say, well, it's 100 minus 30% gives you the 70. But if you're getting something really weird or things with decimals and you're not quite sure, you could say, well, I do 100 minus my 70, and that would give you the 30. Because doing it that way would work out for any number of decimals you have. So that wraps up that question. So now we're 2/3 of the way there. We've solved for when the unknown is here in the percent, and we've solved for when the unknown is going to be that new cost after the percent discount. So the thing that we have left now is going to be, well, how do you get that original, if that's where our unknown is? And that brings us our third and final example. So example 3, I was looking online, and Burton snowboards are now 10% off now that we're partway through the season. So snowboards are 10% off. And they had one, I don't know if I'm saying this right, but the Antler Blem is right now $584.95. And the question is, what's the original price? So what's the original cost? So what would you have paid, or what would your parents have paid if they would have bought you one for Christmas a month ago? And I'm going to start out with that same, well, we're going to do in the percent times the original equals the new. And just another plug, if you're showing your work, the people that show their work, they're most often the ones that get the A's. So write out the equation. And it's tempting to just right away go and throw in a 10% right there, but you have to remember, okay, we're doing percent discount, so we're not paying 10% of the original cost, we're paying 90% of the original cost. And you get that by doing your 100%, take away the 10%, you're left with the 90% that you pay. So you need to make sure you put in your 90, you're not getting that great of a deal. And the original, well, that's what we're trying to find, so that's the X. And that gives us the new cost right now of $584.95. And if we're solving for X, well, you look at what was done to X. X was multiplied by 0.9 to give me this new number. So we need to do the inverse of multiplication to undo it. So that means we divide both sides by 0.9. And then that says to us, all right, my original cost was $649.95. You're actually getting a pretty decent savings. 10% of a big number starts to add up. But that there now would be your original cost of the Antler Blem snowboard. So that's it for this section. You have the 3 different examples. One where you're trying to find the new amount, one where you're trying to find the percent, and this third example where you're trying to find the original. If you can do all 3 of those, you should be able to rock all the questions from this section. Let me know if you have questions.